Hello everyone, I'm João from That's Brilliant. In this video, we are going to talk about the difference between temperature and heat. And temperature and heat are very important concepts in physics. They are related, but they are not the same thing. So we're going to see the differences between them. So let's start with temperature. And we know that this is related to something to be cold or something hot. But imagine you have an ice cube and boiling water. And which one of them has a higher temperature? Which one of them is hotter? So we know that boiling water is hotter than an ice cube. You can feel that. If you touch boiling water, and maybe you shouldn't, but you know that the temperature of the boiling water is higher than the temperature of the ice cube. We know that boiling water is hotter than the ice cube, but it's just a feeling. You can feel it, but what's physically happening? If you touch something that has a different temperature than other one, you can tell which one is the hottest. But this is a feeling. But what's physically happening to something to have a higher temperature? So what's temperature? Temperature is the measure of the particles agitation. You can say also the measure of the particles speed. And this is very intuitive. If you have boiling water and ice cube, boiling water is hotter. And this means what? Well, the molecules, the particles of the boiling water are the same molecules than the ice cube. They are both water. All the molecules of boiling water and ice cube are made by 2 atoms of hydrogen and 1 atom of oxygen. But what is happening to the particles, the molecules of boiling water, for it to be hotter than the ice cube? So the particles, the molecules of the boiling water are moving faster. They are moving with more speed. They are more agitated than the particles of the ice cube. The particles of the ice cube, they are moving less. They have less speed, they are less agitated, and they are vibrating less than the particles of boiling water. So this is intuitive. Temperature is related to the speed. The higher the speed of the particles, the higher is the temperature. And now what's heat? And heat is energy. It's a type of energy. Heat is thermal. Let me write it again. Heat is thermal energy. You can also say this is energy of molecular motion. So the heat is related to temperature, but temperature only depends on the speed of the particles. Heat, besides depending on the speed of the particles, it also depends on the amount of particles, the mass of the object, and also depends on the type of particles. So heat depends on the temperature, on the mass, and on the type of particles. So they are related, but they are not the same thing. Heat is energy. Heat is energy, but temperature is just a measure of it. So let's imagine a situation here. Let's imagine we have 2 different objects and they have different temperatures. And I'm going to represent the temperature by the size of the particles. Not necessarily the size of the particles are the way you're going to draw them, but the size I'm going to use is just to represent the temperature. So the way I'm going to draw, the greater the size, the higher the temperature. So imagine we have an object of low temperature and we have another object of higher temperature. So I'm going to draw the particles of the second object higher just to represent the temperature is higher. Not necessarily the particles are bigger, but I'm just doing this to represent the higher temperature. So we have a second object with a higher temperature, than the first object. And this means that the particles of the second object are moving with more speed, they are moving faster than the particles of the first object. And then we are going to put both objects in contact. And it's going to happen heat transfer. And nature, the universe, looks for equilibrium. So naturally, what's going to happen is heat is going to be transferred from the hottest one to the coldest one. So all the time you put objects of different temperatures in contact, there is going to be heat transfer from the hottest to the coldest one. And this heat transfer is going to happen until all the objects reach the same temperature, the temperature of equilibrium. So imagine what's going to happen next. After this happens, both objects are going to have the same temperature. So they're going to be something like that. The particles of the objects, after they reach the same temperature, are going to be moving faster than the particles of the initial particles of the first object, but slower than the particles of the second objects were initially. So they're going to reach a temperature, an equilibrium temperature. It's going to be between the two first temperatures. I'm just trying to draw to represent that. But it's basically this. Imagine I have here a temperature T1 of the first object initially, a temperature of T2 for the second object, and then after they reach the temperature of the same temperature, they're going to have a temperature T. Both objects are going to have the same temperature T. And we can say that T is less than T2, but greater than T1. So the temperature of equilibrium after two objects reach the same temperature is going to be between the two initial temperatures, not necessarily in the middle. For example, if you have 10 and 12, the final temperature is not going to be necessarily 11. It can be different from this. It can be closer to T2 or closer to T1. It depends on other variables you're going to see in future videos. But this is basically what happens. Always the hottest object transfers heat to the coldest one. And this transfer is not necessarily, it isn't that the heat is walking to the other object. It isn't just moving heat from an object to another one. What's really happening is that the particles of this object starts to move a little bit slower. And the particles of this first object starts to move a little bit faster until they reach the same speed, that is, the same temperature. So this is it. Thank you very much for watching and see you in the next video.